Okay, so this topic we are talking about enthalpy. Okay, enthalpy is another terminology we are using for heat energy. Okay, or energy, we can say basically it is another term for not just heat energy, all energies. So we can say energies. Okay, basically, this is used only if a reaction happens in constant pressure. So, most of the time, whatever reaction we are doing in our lab, they are happening in our atmospheric pressure. So, we are using enthalpy a lot. So, it is a measurement of energy in a system or a change in enthalpy occurs when a chemical reaction, change in enthalpy means delta H. That means if a system has H1 and H2, this is initial and final, then delta H is equal to what? Final minus initial. That's a basic change in enthalpy. Okay. During a chemical reaction, we know that in a reaction there we are starting with the reactants, then reactants will undergo breaking of bond, formation of bond, and resulting in what? Products. So they both have different energies. So the difference in their energy is called change in enthalpy. We show the amount of energy if they are absorbing or whether they are releasing during a chemical reaction. So the symbols we are using, I already said we are using delta H, or basically you will see whenever you read the textbook, you will see delta H of reaction. Then unit will be, the delta H is always expressed in kilojoule and per reaction. And if the reaction is the reactants, we are starting with 1 mole of any reactants, then we can say, or 1 mole of the product, we can say kilojoule per mole, but it is not always true. So we will use kilojoule per reaction. Okay, so there is a mistake in your note. This formula may be written based on enthalpy. Just change that into bond enthalpy. Okay. So this is how we are going to calculate enthalpy change for a reaction. Okay. Bond energy, this is bond enthalpy. You can say whenever I said enthalpy, it is energy. You have to connect to both terms. Okay. Bond enthalpy of reactants minus bond enthalpy of product. Okay, if more energy is needed for breaking the bond of reactants compared to the products, that means that reaction will absorbing heat. If it is in the other way, it will be releasing heat. So to calculate enthalpy of product and enthalpy, you reference sheets are given there. The bond energies are given. Okay. So then remember this. If the bonds are breaking, we have to apply energy. They need to absorb energy, right? If bond is forming, they will release energy because they are getting more stabilized. More stabilized means the system needs only low amount of energy, so they will release energy outside. Okay, so the difference between the enthalpy of reactants and products determines whether the energy is released or absorbed. The reaction may be exothermic or endothermic. Remember the demonstration we did, okay? When you mix two reactants, if you are feeling hot, that means that system is releasing energy outside. So you are the surroundings and you are feeling high temperature. That means you are getting energy from the system. So that type of reaction is called exothermic. And endothermic, we did that example also. If you feel cold, that will be getting energy from outside for the reaction. That means it is absorbing energy from you to do that reaction or from the surroundings. That's why you feel cold. That is called endothermic. Easy way to remember: exo means exiting energy and ento means energy is entering. Okay, use that words to remember that. Okay. Okay, so we account for the change in enthalpy by writing. We can calculate the change in enthalpy by writing equations. Okay, so writing a equation which included heat, that is called thermochemical equation. Say for example, this reaction says hydrogen combines with oxygen forming water, and you can see a product, one more product, there is a heat is releasing as a product. If a heat is a product, that will be what? Exothermic reaction. So if you are seeing another way, like say for example, that example is not given here. Say for example, N2 plus H2 plus a specific amount of heat giving 2NH3. That means heat is as a reactant, that will be what? N2. Okay, then another way of expressing it's not a thermochemical equation like we are expressing, showing the energy in a reaction, that is by writing like this. So write the equation, then put a comma, write delta H is equal to negative this much. If it is negative, that means it is releasing, we know that system is losing energy, that's why we indicated the sign with the negative, so that will be also exothermic. Or other way, another example, N2 plus 3H2 producing 2NH3, and if you are writing delta H is positive a value here, then we will say that is endothermic. So delta H is positive, it is endothermic, it is absorbing because system is getting more energy. If it is negative, that will be exothermic. Good. Okay, let's go see this. This one gives the bond enthalpy, bond energies of different bonds. So we are going to use these values when we are doing the calculations. Okay, on your test we will provide the bond enthalpy and you are going to calculate the enthalpy change for the reaction. Okay, so here is a problem. You have to write the equation by yourself. We will give you only the word equation. So it says nitrogen plus hydrogen producing ammonia. So I'm gonna write, you know the symbol, this is N2, this is H2, and this is NH3, right? And you have to balance equation. We know that this will be 2, this will be 3, okay? And I'm gonna write nitrogen, and maybe you have to refresh your Lewis dot structure. Nitrogen has a structure in triple bond N. You don't need to show the Lewis Lewis dots in structure because we are worrying about only the bonds. So N2 plus 3 molecule of H is having only single bond like this, and it is producing 2 of ammonia, and you know the structure of ammonia. Okay, so the lone pairs are there in case you are curious, but we don't need that. Okay, so now we have to find the enthalpy. We know that the enthalpy change is equal to bond energy of the reactants minus bond energy of product. Okay, let's go ahead and find N triple bond N value from the table. It says what? N triple bond N is 941, and all these answer values in kilojoule per mole because it is talking about only 1 mole. Okay, so this 1 mole of N is equal to 941 kilojoule per mole first. And hydrogen, there are 3 hydrogens, so you have to multiply because it is only 1 mole is given in the table, so that is 436. So you will multiply with the 436 kilojoule per mole. Okay, so whatever value you are getting, that is the bond energy of reactants. Okay, now to find the answer, this is equation, right? The equation is what? Reactants minus product. If you want to write that here, we can write, okay? Delta H, we use a different color. Delta H is equal to bond enthalpy of reactants minus bond enthalpy of product, or so you can say bond energy of products. Okay, so now we are minusing. You have to do this operation first, then minus 2 times NH bond. NH is what? What is the value? 391. But how many NH bonds are here? 1, 2, 3. So you have to multiply again with the 3 times NH. What was the value? 391 kilojoule per mole. Okay, so we'll do this and subtract, and that will be the final. You will get the final answer. Let's do the calculation. So the final answer, you will get 97. Delta H is equal to 97 kilojoule per mole. Let me double check that. Double check the calculation. So it is 941 plus 3 times 436 minus 6 times 391. Okay, that is 97 kilojoule per mole. I think it is negative, okay? Okay, let's do one of the word equation and come back, okay? So methane plus oxygen forming carbon dioxide and water, okay? So methane is CH4, so we are going to draw the structure like this, and I have recorded another video for drawing the structure of organic compounds. Just go watch that if you need help. So this giving CO2, which is this, plus H2O. Okay, we need to balance. There is one carbon, 4 hydrogen. So I'm going to write this 2. Then there is 2 plus 2, 4 oxygen. So this will be 2. Okay. So now we are going to calculate that CH bond. CH bond is 413. 413. So there are 4 CH bond. I'm going to write 4 times 413, and it is kilojoule per mole. Remember that. Plus 2 times oxygen. We need O double bond O, which is where is O2? It's given here. Okay, 495. 495 kilojoule per mole, minus, then it is minus, whatever, it's minus 2 times C double bond O bonds, which is 799, 799, plus 2 times, there is again 2, so that is 2, there are 2 bonds, a total 4. Okay, so 4 times OH bonds, which is O single bond H, O single bond H is 463. Everything is in kilojoule per mole. Okay, 463, and these are also kilojoule per mole. All the tables are given in kilojoule per mole. Then do the calculation. Let me do the calculation for the really quick. So it is, we are starting from 4 times 413 plus 2 times 495. Okay, then minus 2 times 799. Okay, then we had to start a parenthesis. Okay, then plus 4 times 463. Okay, close the parenthesis, close the parenthesis. So that will be negative 80, negative 808, negative 808 kilojoule per mole, right? Yes. So that will be final answer, which is negative 808 kilojoule per mole. Okay, so that's how we have to do it. Let's go start from the second one, or you need to continue with this, whichever one you want to do it. Let's do that. Okay, this one. Okay, this one says hydrogen. Let's check its balance. Hydrogen plus chlorine giving 2 times HCl, right? Okay, so let's go find the value for HH, which is 436. Okay, plus Cl, single bond Cl, which is 242. So you had to add this, then subtract 2 times hydrogen and Cl, which is 431. Okay, let's do the calculation. Okay, so after this question, I'll skip the calculation part because that is taking too much time. You can calculate. So 436 plus 242 minus 2 times 431. So that will be negative 184 kJ per mole, right? I don't have space to write it. I'll write down the bottom. So that is negative 184 kg per mole. So that's how you are doing it. The next one, C2H4. Okay, so the carbon, there is a video for drawing how the carbon compounds. I'm gonna draw like this, and there are two hydrogen, one here, one here, one here, total four hydrogen. To complete the valency, I'm gonna draw a double bond. Okay, plus F2, there is only one valency, and then same strategy, C. There are two, four hydrogens. I'm going to put one hydrogen here, one hydrogen here, one hydrogen here, one hydrogen here. Then there is two fluorine. I'll put one fluorine here, one fluorine here. So those are the bonds. Then you have to find the bond energy of C double bond C. So C, there is one C double bond C. I'll write with a different color. This is one C double bond C, which is 614. 614 plus there are four CH bond. CH is where is CH? CH is 413. So there are four. So I had to multiply with the 413 plus there is one FF bond. FF bond is here, which is 155. 155. So you have to add all this and all of this in kilojoule per mole. Then minus, okay, there are 1, 2, 3, 4 CH bonds. So it's the same value. So I'm going to multiply 4 times 413. Okay, plus there is one CC bond, one CC single bond C is 348. So you are going to write 348. Okay, and plus there is 2 CF bond, right? So 2 times what is the CF bond is? CF is 485. So you are going to do that and everything in kilojoule per mole, add and multiply, add and then subtract. Then you will get the answer is negative 549. Negative 549 kilojoule per mole. Okay, so these are the strategies we are going to use. I'm going to give you the structure because that will be the difficult part for you as of now. Then calculation you have to do by yourself rest of the question. So hydrogen peroxide is this. Okay, plus hydrogen peroxide is H2O2. Okay, giving water, you know the structure for water and oxygen, and you have to balance the equation also. Okay, so there is 2 oxygen here, there is 3 oxygen on the right side. So you have to put this into 2, this into 2, then there will be 4 oxygen, so 4 hydrogen. I think that is balanced now. Okay, so then remember there is 2 times how many OH bonds? There is 1, 2, 2 OH bonds, then so that is 4, right? 2 times 2. Okay, then 2 times 1 OO bond. Like that you had to calculate and do the calculation. Then propane is C3H8, we know that. So you are going to write 3 carbons in a single line and fill the hydrogen until they complete all hydrogen. So these are the structure for propane. Okay, and oxygen, you know that oxygen is O double bond O, carbon dioxide is C double bond O, plus water is HOH. Okay, then do the calculation and remember you have to calculate all the bonds. Okay, Next one, carbon dioxide and water, C double bond O plus H2O, which is HOH, and glucose, C6H12O6. That is the formula for glucose. So you can write 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and all these carbons you can write HO, HOH, HOH, H. This is not the actual structure, there is some difference, but you just need to know the bonding, right? Okay, then this will be HOH. Okay, so there is 5 oxygen, and how many hydrogen? 3, 6, 10, 11. There we have one more oxygen, one more hydrogen and one more oxygen. So that is the actual structure for glucose, plus O2, which is O double bond O. Okay, so remember here there is one, how many, oh that's not a good color, there is how many CH? 1, 2, 3, 4, 5, 6, 7 CH bonds are there. Okay, and how many CC bonds? Okay, so CC bonds are 1, 2, 3, 4, 5 CC bonds. Then OH-CO bonds, you have to calculate the CO bonds. Why can't be colors? Okay, so CO bonds are 1, 2, 3, 4, 5 CO bonds. Then OH bonds are 1, 2, 3, 4, 5. Okay, then what else we have? We have one CO bond. So you have to calculate all of this. Maybe if you all need help, I can do that questions. And remember, you have to balance equation. This equation is not balanced, right? So how to balance a 6 carbon on the right hand side? There is only 1 on the left hand side, so I'm going to multiply this with the 6. Okay, then hydrogen, there is already 12 there. So 6 times 6 is 12, 6. So we are going to multiply this with let me see, 3 oxygen and 3. Okay, so that will be 3 times 2, 6. Okay, oxygen will be 6 times 2, 12, plus 3, 15. Okay, that won't work. We need double numbers, so I'm going to double this, 6. Okay, so now hydrogens are 6 times 2, 12. So yeah, that's pretty much it. Let's add a 6 here. So let me erase that and put that. Okay, so this is 6 and this is 6. Okay, so now we can go calculate. So I'm gonna list all the bonds here. So 6 times, there is how many CO bonds? 2 CO bonds. Okay, so so 6 times 2 will be how many? 12 CO bonds. Okay, so we are going to multiply this with the 12 CO. What is the value for COA? C double bond O is 799. So you are going to multiply 12 times 799 kilojoule per mole, and I'm going to start a parenthesis or a bracket. Then 6, there is 2 OH bonds. 6 times 2 is again 12 times OH is how many? What is how much? So let's go find OH value, which is 463. Okay, so OH is 463. So multiply and add, then subtract. Okay, you have to subtract. You are going to add a minus symbol, minus, then start a parenthesis. There are so many, right? So CH bond 1, 2, 3, 4, 5, 6, 7 CH bond. So 7 times CH is how much? 413. Okay, 413 kilojoule per mole plus, then we need O bonds. Okay, we need a CC bond. How many CC there? 1, 2, 3, 4, 5. So 5 times CC. This is CH. Okay, then 5 times CC is how many there? There is 300 and something like that, 348. 348 kilojoule per mole plus, then look at CO bond. There is 5 CO bonds, right? So 5 times then CO is CO single bond 358. So CO is 358. That is CO. Okay, plus then OH bonds. Okay, how many OH bonds are there? These are the OH bonds. So 5 OH bond. So 5 times, and the value for OH is here, which is 463. 463. Okay, then I am running out of space, so that is OH. Then what else is remaining there? There is there is C double bond O bond there, right? There is one C double bond O bond, which is 1 times. Did we count everything? Like, let me see. Yeah, I think we took CO, OH, CC. Okay, 1 C double bond O bond, which is what? C double bond O bond is 799. 799. Okay, plus now oxygen, there is O. So this is C double bond O plus 6 times O double bond O, which is the last one. Okay, then again close the parenthesis. Okay, let's see what is O double bond O is. O double bond O. Yeah, this is always, you can write that as O double bond O. Okay, it's 495. Okay, so you have to do this calculation. It's a big calculation, and I pretty much did all the questions for you. You can do the rest and then check the answers with me in class.